Hi, Mr. Richards here. Today's lesson is on scatter plots and lines of fit. Well, a scatter plot shows the relationship between a set of data with two variables graphed as ordered pairs on a coordinate plane. Scatter plots are used to investigate a relationship between two quantities. And here we have three types of scatter plots. We have one that has positive correlation, one with negative, and one with no correlation. So we can see in our positive correlation here that generally all the points are going in an upward direction. Kind of have a line that we can almost draw right in here. So we can see, well, look, there's a positive slope here. And basically as x increases, so does y. Y increases. Compare that to negative correlation, where everything seems to be going a little bit downwards. So we can kind of see where there'd be a line right around there. And basically, as x increases, y decreases, as we have that negative slope. And here with no correlation, they're really just all over the place. You can't really say, oh, it's going up, because I could say, oh, look, it's going down. I mean, there is no relationship there. So we could say that x and y are not related. Let's see how this looks in a few examples. The graph shows the average number of students per computer in Maria's school. We need to determine whether the graph shows a positive correlation, a negative correlation, or no correlation at all. If there is a positive or negative correlation, we need to be able to describe its meaning in the situation. Well, as I look, things seem to be going in a downward direction here as my time is going on. My students per computer are going down. Means we're getting possibly more computers in the building. So what we can say here is that there is definitely a negative correlation. There's a negative correlation. Now, for our description of the meaning, this is just one possible sample, but we could say each year, Maria's school has more computers lowering the student per computer rate. If they're getting more computers, then the average number of students per computer is going to go down. What about this graph with mail order prescriptions? Same directions, positive, negative, or no correlation, and describe its meaning if there is a positive or negative correlation. And I hope right away that you can see that we're going pretty linearly, actually, in an upward direction here. So we could say that this is a positive correlation. And as we look for this description, we can say that each year, more people are taking advantage, or just more people are using mail order prescriptions to get their medicine. Now, let's go into lines of fit. Now, lines of fit are also called trend lines, and we'll see what that looks like as we graph this. The table here shows the world population growing at a rapid rate. Identify the independent and dependent variables and make a scatter plot to determine what relationship, if any, exists. Well, we need to be able to identify our independent and our dependent variables first. Independent and dependent. Well, our independent variable, that's our year. Years just keep going independent of anything else. Our dependent variable is our population. Let's squeeze that in there. Now, we need to make our scatter plot. Now, our independent variable typically goes on the x-axis, so we can write our years there. And here we can, each line can represent 100, so 1,000 or 1,500, 1,600, 1,700. I'm going to, because of space, label a couple of these, 1,900 and 2,100. And yes, that there is 1,600 here. There is 1,800 here. And 2,000 here, so we'll just get them all labeled. Our dependent typically goes on the y-axis, so this is our population. And our population here is special. It's in millions, so we do want to make a note of that as we graph it, so we don't accidentally think that there were just 500 people here in 1650. No, there's 500 million and 1,000 million, which is also a billion. But either way, as we go to graph this, 1650 is at 500 million, which we have not labeled yet. Let's do that real quick. Let's count up by 1,000s. All the way to 7,000. Now, 1650, once again, is at 500 million, so that's going to be somewhere in this general neighborhood in between everything. 1850 was up to 1,000 million, so that's going to be right around here. 1930, well, that's 2,000 million. So that's going to be right around here. 1975 was up to 4,000. In the year 2004, we had 6,400 million, or 6,400 million, which we can graph right around here. Now, as we look at our correlation to determine what relationship, that's our correlation, we're going, as the years go on, our population is definitely increasing, so we can say that we have positive correlation. Since again, as our x increases, so does our y. Now, as I go to draw a line of fit, or a trend line, we're going in this upward direction. We can't include them all. We're not going to create a curve, but we want to kind of try to look for a line that fits everything as best as we can. And I think that that is going right about there. Again, not perfect, but there. Because we have one point to the left of the graph, we have these two to the right, and it's pretty representative of what's going on here. We do have two here to the right and only one to the left, but this one to the left is much further away, so it kind of balances itself out. Now, with this trend line, we can create an equation in order to eventually make predictions based on this graph. So, using 2 points on the line of fit to write an equation for the line is our third step, and we need to find the slope. Well, we need 2 points to find the slope. And so let's use the 2 points that are actually here on the line. And those points, of course, are 1850 and 1,000 million. And our last point was 2004 and 6,400 million. And if I label x1, y1, and x2, y2. As I go to find my slope, slope, remember, is y2 minus y1 for our formula, minus x, or over x2 minus x1. And our y2 minus our y1 over our x2 minus our x1. And as we continue here, that's 5,400 over 154. And we can actually just divide these two numbers, 5,400 divided by 154, to get 35.06. So that can be our slope. Now, when we want to write the equation of the line of fit, let's start off in point-slope form, which is y minus y1 equals m times x minus x1. We have, pick a point. Let's pick the 2004 point. Y minus 6,400 equals 35.06 times x minus 2004. And we can distribute here and get y minus 6,400 equals 35.06x minus 70,260. Now to get this into y equals mx plus b form, add that 6,400 to both sides, and you would end up with y equals 35.06x minus 63,860. That's a comma there. So y equals 35.06x minus 63,860 is our equation for this line. And that's just a sample answer. You may come up with different equations as you pick different points for your line of fit. This is just the equation for this line of fit that we drew. Now, if we use this equation to predict the world's population in 2025, let's rewrite our equation. Y equals 35.06x minus 63,860. We are going to put the 2025 in for x. So y is going to equal 35.06, since our x were our years, minus 63,860. So y is going to equal 7,996.5 minus 63,860. And so y is going to equal 7,136.5. Now remember, this is in millions. So you could leave your answer like that, or you could say there's going to be 7,136,500,000 people in the world based on that equation. Either would work. Let's try this one more time. This table shows the number of bachelor's degrees received since 1988, where these are our years since 1988, and these are our bachelor's degrees received in thousands. Once again, we're going to identify the independent and dependent variables to make a scatter plot, to see if there's a correlation, and possibly draw a line of fit that's close to most of the data points. Well, let's identify our independent and dependent variables first. And once again, our independent variable is going to be our years. That's our time. And so our years are going to go on the x-axis once again. Whereas our dependent variable, that's going to be our degrees. So our y-axis is going to be our degrees received here. And again, that is in thousands. And so, as we label this, we can label, okay, 2 years since, 4 years since, 6, 8, and 10. And then when we look at our y-axis, we are actually going to show this what's called a break in the graph, where we can draw this little squiggly line there with the graph to show that, okay, I'm going to skip from the bottom, which was 0, in order to show a more effective graph here. On our graph, I'm going to choose to count by 25 here. So we're going to start with the 1051, or 1050 at least, to 1075, 1100, 1125, 1150, 1175, and then 1200. And those of you wondering how did I come up with that, I subtracted 1184 minus 1051 divided by the number of lines I had, got about 16. So I could technically count by 16 here, or I looked at the numbers and 25 is close enough, that'll get me what I need. So, as we go to graph this now, 2 is at 1051, which is just right around here, just above that line. Can barely tell the difference here. 4 is at 1136, which is going to be somewhere around here. 6 is 1169, which is somewhere right around here. 8 is at 1165, so we actually came back a little bit here. And then 10 is at 1184, so we went back up, right around here. Now, when we go to draw our line of best fit, we need to first look at what's my correlation. Well, it does seem as time's going on that our degrees are increasing. So for this one, we can write that there is a positive correlation. And when we look to draw our line of best fit here, there's not a great one, but I can kind of see a line starting where we were and going up in between the points. So I have 2 on the top of the line and 2 below the line. That might be our line of best fit here. Let's go ahead and draw the line going up, as much of a line as we can. You have 2 points to the left of it, 2 points to the right, or 2 points above, 2 points below, and that's our line of best fit. Now, in order to find slope, one thing you can also do, and it's kind of a creative way of solving this, I do have this point here that's pretty close to 1050, or you could just call it the 1051. I mean, that's pretty much exactly there. And then as I look up my graph here, neither of these 4 points, none of them are on my line, so you get to come up with your own. You get to see, okay, where along this line can I pick a point that I actually want to calculate with? Well, I'm going to pick right here, because it looks like it's at the perfect intersection of 6 and 1150. So that's going to be the point that I pick to calculate my slope and to work out the rest of this problem. So my 2 points, 2 and 1051, and then 6, and it's a little sloppy up there. I can barely read it. Let's rewrite that as 6 and 1150 here. So I can label these x1, y1, and x2, y2. So when I calculate my slope using the formula, y2 minus y1 over x2 minus x1 gives me 1150 minus 1051. Almost wish I changed that to 1050 there. And then over 6 minus 2. That's going to be 99 over 4. I really wish I would have changed that to 1050 now to come up with a better number than 99 over 4. But 99 divided by 4 is 24.75. So I can say the slope of this line is 24.75. Now, in order to write the equation of the line of fit, we can again start in point slope form. Y minus y1 equals m times x minus x1. Pick one of the 2 points. I'm going to pick this 6, 1150 here. So y minus 1150 is going to equal my slope of 24.75 times x minus 6. Since again I picked this point here. Well, as I go to simplify, y minus 1150 is going to equal, as I distribute, 24.75x minus 148.5. And as I look to simplify here, I can add this 1150 to both sides. And that cancels out. And just so I can have more room, I'm going to come up here and finish. Y equals 24.75x plus 1001.5. Try to rewrite that there since we're running out of room. Plus 1001.5. There we go. You can see that now. And that's my equation. Y equals 24.75x plus 1001.5. Now let's use that equation, y equals 24.75x plus 1001.5, to predict the number of bachelor degrees received in 2015. Well, here we have to be careful. Our years were counted since 1988. So first we have to say, well, how many years has it been to put in for x? So 2015 minus 1988 is 27 years. So I can put in then that 27 years since 1988 in for x. When I multiply that by 24.75, you get 668.25 plus the 1001.5. And your final answer here, y equals 1,669.75 thousand degrees, which is the equivalent of 1,669,750 degrees. But if you want to just keep it as 1,669.75 thousand instead of 1 million, that works too. That's it. Good luck.